We have a right triangle, except the side lengths aren't ordinary numbers. They're all exponential expressions. Take a look. The hypotenuse is 2 to the power of x. The horizontal leg is 4 to the power of x. And the vertical leg is 8 to the power of x. Our challenge is simple. Find the value of x. Now, before doing any calculations, there's something unusual here. Normally, 8 to the power of x would be larger than 4 to the power of x, which would be larger than 2 to the power of x. So why is 2 to the power of x the hypotenuse? That can only happen if x is negative. As soon as the exponent becomes negative, the size relationship flips around. So we've already discovered our first clue. X must be less than 0. Now, let's bring in the Pythagorean Theorem. Leg squared plus leg squared equals hypotenuse squared. Substituting our side lengths gives 4 to the power of x, all squared, plus 8 to the power of x, all squared, equals 2 to the power of x, all squared. When a power is raised to another power, we multiply the exponents. So this becomes 4 to the power of 2x plus 8 to the power of 2x equals 2 to the power of 2x. Now, let's rewrite everything using base 2. 4 is 2 squared, and 8 is 2 cubed. So our equation becomes 2 to the power of 4x plus 2 to the power of 6x equals 2 to the power of 2x. At this point, every term involves 2 to the power of 2x. That suggests a very useful substitution. Let's let a equals 2 to the power of 2x. Watch how clean the equation becomes. A squared plus a cubed equals a. Moving everything to one side gives a cubed plus a squared minus a equals 0. Every term contains a factor of a, so let's factor it out. We get a multiplied by the quantity a squared plus a minus 1 equals 0. Since a represents 2 to the power of 2x, it can never be 0. Exponential expressions are always positive. So the only possibility is a squared plus a minus 1 equals 0. And now we've arrived at a classic quadratic equation. Using the quadratic formula, we get a equals -1 plus or minus the square root of 5, all divided by 2. Which solution should we keep? Well, a is an exponential quantity, so it must be positive. That means we discard the negative solution, leaving us with a equals -1 plus the square root of 5, all divided by 2. And here's a fun observation. This number is actually the reciprocal of the famous golden ratio. Now, let's undo our substitution. Since a equals 2 to the power of 2x, we have 2 to the power of 2x equals -1 plus the square root of 5, all divided by 2. To solve for x, we take the logarithm of both sides. The exponent comes down in front, giving 2x times log 2 equals log of the quantity -1 plus the square root of 5, all divided by 2. Dividing both sides by 2 log 2 gives x equals log of the quantity -1 plus the square root of 5, all divided by 2, all over 2 log 2. Evaluating that expression gives x is approximately negative 0.347. And that's exactly what we expected from our very first clue. The exponent is negative. If you enjoyed this puzzle, don't forget to subscribe for more beautiful mathematics. I'll see you in the next one.